Now, my next message is efficiency plus quality equals competitiveness, or vice versa. Integration of design, construction, structural manufacturing, and exploitation and operation. Integration of all these projects or cycles of the building together. This integrated building cycle management. Who knows what Open BIM is about? Well, BIM, everybody knows BIM, but who has heard about Open BIM? You see the logo out there. Raise your hands, please. Show of hands. Okay, right, so we see hands here. Great, perfect. Who of you knows the international organization Building Smart? Vladimir must know, but the other guys know. Yes, some hands raised in the audience. So I would like to introduce you to these notions, to this organization in particular. Let me give you an oversight of it to open your eyes wider. Why am I doing that? To give you a choice. This is the most important point, being flexible, being able to choose. Oh, I'm sorry, I didn't introduce myself this entire time. I'm the manager of BIM Solutions Group. My name is ERNESTAS, and we have a company in Latvia, Lithuania, and now a branch office in Belarus. Let us start from some facts and figures. This is the Danish statistics dating back to 2010. The Danish guys made a poll for their construction companies, and they asked these questions. Which issues are you facing in construction? So it's not like 100% of construction companies have been polled, but the vast majority have. What are the worst challenges, worst issues they have pointed out? It's communication and cooperation. 61% have said that these are the problematic points. Running second, 45% of respondents said that quality of project is poor. Planning and organizational work. Quality of materials, problems with project implementation, and running down to the least important, or to the least challenging. But if we focus on the key problems, on the key challenges, the ones highlighted in red, first, second, and third, communication and collaboration, that's as easy as it sounds. Designers with constructors, designers with manufacturers, customers with all the stakeholders, with technical oversight body. So it's all about this. It's the communication and cooperation between the participants of the project. And sometimes very basic problems arise just because we fail to understand each other. We fail to agree properly on all the points. One person says one thing but means the other, and the problems of miscommunication can arise. We have so much information around us in our life that sometimes we fail to catch it and process it in time. There's different things, so the different processes, but still you get the point. So I would like you to center your attention today around these three key challenges: communication and collaboration, project quality, and planning and arrangement of works. So it will be interesting for you to have a look and to be familiar. There is another company in this area, but I will voice its outcomes later. According to the Building Smart International Organization, they have conducted a poll and to identify what this communication and collaboration is about. What is meant by that? 20 or 30% of losses occur at this stage. Well, losses or waste, yes, I believe this is the right word I'm using in Russian here. It's losses or waste. It's losses that have occurred due to miscommunication. I will show you a video of our general contractor of ours. It's one of the strongest in Latvia. And they will, the situation is pretty simple. They are completing one project, and they have used a very decent organization to help, a very decent company to help them there. And they have increased the pace of project implementation twofold. they had a certain surplus that could have been wasted if not optimized. So 20 or 30%, up to 30%, it's just because of communication or lack thereof. Communication and lack of collaboration can cost you up to 30% of your time and money. If I had more time, I would give you specific examples from our Lithuanian projects. But feel free to think about your projects when I'm referring to Lithuanian ones. They're not that far apart. So it's about integration of all the projects. These are the stages we can describe. It's not all over the place, and it's not all over the countries. We're talking about conceptual design, we're talking about design development. So I would like to say that this is more or less in line with the Belarusian architectural design, right? Why is it architectural design? What? No structural engineers work there. They do. And there's a confusing name for it. Electricians, engineers, the heating guys, the MEP engineers, everybody's involved. In some other methodologies, the next stage is production, or typically it's a construction phase, according to the Belarusian norms. If I'm wrong here, please feel free to correct me. I might not know all the details. So it's the construction project. So in parallel, we have these gray areas below are construction and fabrication. Preparation, construction plus fabrication, and we were supposed to start there physically, to start fabrication. Manufacturing comes hand in hand with construction process. If you only focus manufacturing, then I strongly doubt that your projects will succeed in terms of planning. We cannot just plan separately the construction works without paying attention to the plan of production, plan of fabrication, plan of delivery, the logistics of it all. So this is all in a very tight intertwined. And this connection, this joint, this links, or linking all this together is the key success factor. It also comes as no secret. There are people who are doing the construction project, construction design. And there's got to be an interface to talk to them, or to communicate with them. I can simplify a bit and say that BIM essence, or BIM essentially, is about creation of information, creation of data, exchanging the data, and then passing it forward, passing it on to the next level. Using information systems, using this information, using this data, it must be used during the ongoing further processes. If we have created some project, or if we have created a database, but nobody's using it, what's the good of it? If you created a BIM model, but the designers or the constructors are saying, I don't care about your BIM model, give me the drawings, I need to work by the drawings. So the question arises, why did we do BIM in the first place if not all stakeholders are going to use it? So the entire day of the conference will be dedicated to this, BIM, and how to streamline it properly. First of all, it's two levels of integration, horizontal or vertical. It's integration between the participants and between the processes. So you realize what this process is about, right? So let's imagine another circle. BIM is an information system if we stop time, if we stop the time. But essentially it's a process. It's a process of creation and transferring the information. This circle it's like a spiral. It's spiraling throughout this entire process. This is what BIM is about. It's integration between the stakeholders, between the participants of the projects, and further down the process. So this is where we find ourselves. There are several examples practical examples that we can refer to both in Latvia, Lithuania, and abroad. I am very much for studying from other people's mistakes, but not our mistakes, or not your own mistakes. But there are companies in Lithuania that choose to learn from their mistakes. These lessons are very painful, but very precious at the same time. You will never forget the bad mistake you've made in a long while. The BIM will be successful when there will be architecture around it, and all the engineers, all types of engineers, will be streamlined and will be working in an integrated environment. BIM is about simultaneous or streamlining of workflows. Who is using BIM in more than one design phase? Architectural phase, design, people are using that. Do you agree that BIM is about streamlining the processes? Yes, you agree. Okay, and what about you? You also agree, right? So it's the definition of BIM in that regard. First of all, BIM is about saving time, just because we start several processes simultaneously. It's more streamlining, better optimization. Another thing that we're aiming at is working in an integrated environment. I'm an electrician. Okay, I may not look like an electrician, your average electrician, but please, this is the fact. And I do have software for connection various joints, communication networks, electricity networks, and others. So if I'm an electrician and if I work in an integrated environment, what does that mean? That means that I get to see the output of architecture, the output of designers, of structural engineers in my software, right there where my communication networks are. This is what working in an integrated environment is about. There are other options. We have a multitude of those options in Lithuania. Sometimes they choose to do all the projects individually in a standalone manner, and then they try to fit it together. Misfit, okay, they come back and redo the project or adjust the project and then try to fit it back together. You see the difference, right? So you do once and you have done everything in one go instead of several goals without this guaranteed success. So we have these practices that we can compare from. Okay, moving on. Constructors and manufacturers, fabricators are using BIM to control planning, logistics, without, or to go drawing-free production, drawing-free manufacturing. And I'm pleased that in some cases in Belarus, for example in Gomel, I have seen that. Drawing-free or drawing-less designs of various pieces, for example. It's a limited practice so far in Belarus, it's a big practice in Latvia, and it's a very big practice in the Western world. So we have this major metal structures factory, completely robotized, completely automated. And we are considering the stages, how it's all supposed to come together. It's not just about geometry, it's also about the stages. They are sorting the materials, they are hand-picking the materials for every particular project. Mick will be talking about automation of metal engineering, metal production. I believe you will be interested about that. So, what else do we talk about during when we talk about BIM? The bicycle has already been invented. It's just about upgrading it further, making it even better. The documentation is available in English so far, but I've been showing you some standards that you can use and bring order to your documentation. Some of you may already know these standards. I will not go into too much detail. It's not a BIM management session. We're talking about manufacturing, but let me draw your attention to some standards that are being used worldwide. These standards are used to streamline work. One standard I would like to make note of still is the IFC standard, IFC format, and BCF, Building Communication Format. It's another standard. This is a new thing. And in Europe, it's already part of ISO standard. It is now the official standard for BIM. Well, I believe you know what DWG is. DWG or DWG is the drawing format. BIM format or BIM files are IFC files to facilitate the exchange of data between various stakeholders in the project or between the projects. There are many ways to work with BIM. So let's talk about open BIM briefly. Well, open means open. It's pretty self-explanatory, right? So, open BIM. What's it about? Okay. I seem to have serious mistakes in the Russian spelling there, but bear with me, please. So, the BIM is about uniting everyone. There is no single product that will be perfect for everyone out there, for structural engineers, for all types of engineers, for architects, for constructors. There is no such thing. There is no versatile solution, absolutely versatile and fit for everyone. There are customized applications for specific tasks. So we are facing a dilemma. What's better? To have specialized, customized solutions, or have Microsoft Excel that you can adapt to every situation in life. Do you agree that Excel is quite versatile? It's good for accounting. Is Excel spreadsheets good for accounting department? Not really. Well, it could be good, but it's not exactly automated. So this is the difference between the versatile solution like Microsoft Excel and the customized applications like for the accounting department. Each product has its own indication, so to speak. Every program has its field of use. And there is no perfect versatile solution for all the areas out there. Yes, we can reprogram Excel, we can build add-ons for Excel. And I know there are people who do that for Excel. And there are people who can bring Excel around or about any task before them. But it's not what Excel was created for, right? It was a versatile solution to fit as many purposes as possible without being customized for them still. But there are many customized, many tailored solutions that exist worldwide for various applications. So, how do you put all these customized solutions, all these customized projects, technologies together? How do you make them communicate between themselves? And this is what people are afraid about. When you don't know something, you're scared of it. You're afraid of it. But the answer to that dilemma, the answer to that problem is very simple. There are organizations that have been operating for decades now. These organizations are about standardizing the data exchange between various technologies. And BIM standards is exactly it. It's IFC. This Building Smart Alliance, this international organization that I mentioned, they are taking care of this standard. They have created, or they combined all the famous technologies. Bentley, Autodesk. Have you heard these names? Sure you have heard these names. Tekla, Navigix, Rivri, all these technologies are there in this BIM Alliance. And what are they doing? What are they about? They are promoting this versatile standard, this common standard. There will be one speaker from the UK. Nick has brought an adapter for his laptop to make sure he stays on power. So this is about coming up with a versatile adapter, with versatile sockets, so that no adapters will be needed. I'm an electrician, remember? So I am picking the best customized solution for my purposes. But IFC format is something that helps me communicate losslessly with other stakeholders of the process. Okay, I see that skeptical comments like, we don't know whether it's going to work or not. Revit in 2009, it used to even mess with geometry. But now it's not the case. The 2014 version, the most recent version, is alright. Autodesk Revit. It's IFC compatible. It's supporting it. So this is the situation. There are many people in chaos, like everybody is communicating between each other, but not among themselves. And this is the problem. Now, where there is this IFC standard at the center, you see this icon. This is not an icon. It's a logo. It's a logo of IFC format. And feel free to explore what it means. It's like Audi circles, only it's squares and they are in round. Design, procure, assemble, and operate. These four elements come together in BIM. design, procurement, assemble. So pay attention how construction is regarded. It's manufacturing or selling or buying something. So design. Once you know what you design, you start to procure or produce. Then you assemble, put stuff together, and you operate something you've built. So there are various components in this system. There are various applications that consider the maintenance and the operation of the building. And they support IFC. This is that interface that helps everyone talk to each other in a problem-free way. So these are several options of software. If some of you have not been there to our website, bimsolutions.by, please feel free to log on to the website. Now there are more videos, there are more descriptions available in that website. So at least this is some names are mentioned there. The Tekla technologies for designers, for structural engineers, or Eurocode integrated solution. I've received information that Eurocode in Belarus is used. You do Eurocode for monolithic construction, reinforced concrete, and metallic structures. You can pick Eurocodes or you can pick your standards. So what is the question? So how can you take Lira and design according to Eurocode, this Belarusian software? It's not funny to me. So you should be thinking about this designing software which is already based on Eurocodes, which is already designing based on Eurocodes. This is something I'm showing you now, by the way. This RFM software, it can use your SNIP norms, construction norms and principles. RFM has spent 3 years to be certified in Russia for SNIP norms, construction norms and principles, SNIP. So the architects are best off in this case. They have Autodesk Revit, they have Graphisoft. Do you know AutoCAD Graphisoft? You work there, perfect. You haven't just heard. EliteCAD is more German. In German-speaking countries, they use EliteCAD more. And so there are many solutions, perfect solutions for architects. Solibri is the king software, is the best software for BIM model quality assurance, quality check. But we won't go into further detail. Why is Solibri king? It's all described in the website. So today we'll be talking about this BIM cloud, BIM communication. This BIM cloud is the interface between all the software and then some that are displayed in this slide to arrange communication through BIM. So I can use Revit to send messages to my structural engineer to Tekla, and they open my message in Tekla and they understand what I mean by my message applying to their conditions. We'll introduce you another condition. This will be Trimble Connect, another presentation, quite a fresh solution. And in this case, in technological sense, I believe that it's a very advanced solution. So let's move on. BIM for construction. For construction purposes. Now there are a lot of technologies in the world. We've been debating, discussing. People know what Oracle Primavera is, so it's a good thing. You guys know things because you've wondered about things. I can come up with another RIP-IQ system from Germany for that purpose, to manage construction projects. So when we start thinking about how do you properly implement that, for example, RIP-IQ in our region, Central and Northern Europe, or Germany aside, so Eastern Europe, and in the North, only one company is using it. EIT, maybe you've... Why IT? It's a major international company, Skanska company. Do you know it? These are the biggest international giants who are using that. technology. This is the biggest general contractors. Okay, so what I meant by what I just said is that this technology is not used by absolutely everyone so far. 4D. What is 4D? 4D is your 3D model in time. It's fourth dimension. So the fourth D is the time. So you have modeled this construction site, but it's a living thing. It changes over time, and the construction situation can change. These structural elements, these columns, these pillars that you use, these are living parts of a living body, of a living organism. And so you see that 4D model can help you check statuses, can help you check quality using that data. So 4D, the fourth dimension is the time, fifth dimension is cost. So this is the terminology I'm going to use, so please, those who haven't known that, those who didn't know, please know what 4D and 5D is about. So this is starting with from conceptual design, going further to construction project. Construction project, it's not exactly a construction project, right? It's a project understood by constructors. I've seen companies who manufacture this already in this form. This installation level is on the right. So installation details means that you know at once by looking at it where each piece will fit. Up to a single screw, up to a single bolt, up to a single piece. It's the manufacturing level. So the information is produced, specified, adjusted, and it reaches this final level like I'm showing in this slide. The essence of conveying is about conveying information from stage to stage. Detailing, planning the manufacturing, planning the construction, status control, further the processes go, quality control, and final documentation or executive BIM model. We call it the model as-built model in English. So the best, the key thing is about fine-tuning all these processes. It's not just about designing standalone pieces and trying to fit them together. This is about BIM and at the center of it to help there. And this is why we put together this conference. So let's consider the construction model. It's much bigger, it's much wider than the structural model. In construction, we model the construction platform. It changes weekly. So construction site changes over time. We use this fourth dimension to make sure that this living being is alive. It's we're modeling not just these cranes, but also the landscape. We call it in Russian landscape, right? So it's about landscaping. It's about various pits that you need to excavate. In Scandinavia, there are other things that they design. This wooden works. It's not exactly scaffolding. It's scaffolding, right? It's the proper name. So in Scandinavia, they even imitate that when some temporary structures need to be built and what materials will be used for it. But the most important thing is this tree of architectural elements, structural elements, engineering elements. You have seen this, right? So everybody who's working with BIM has already seen this tree. Even if you have worked with AutoCAD, you have seen this tree. But in construction area, we're not happy by just that. We need more. We need additional criteria for every element in the construction logic. First, it's stories. You see stories running from 1, 2, 3, and so on. For example, I am a column. I belong to the story number 1, and I belong to the zone or building A. It's identification of a standalone element. Breakdown of a building by logical pieces, by logical front lines. The best thing that jumps in mind when I'm trying to think of it in Russian. So it's about front lines. There is some piece of some part of work being done, and it is built frontally, like but in zones. It's not like a monolithic construction that will bring and put. It's not like that. It's about zones, and the technologies are supposed to be supporting this logic. That, for example, I am an element, a standalone element belonging to a specific zone, a specific story. So this is additional information, additional description, additional attributes for a specific element. And on the other hand, when some planning is done around me as a standalone element, as a column, so they have planned that tomorrow I am exiting the designing phase, and the column needs to be manufactured in this time frame, in a specific time frame. There is a deadline. There is a deadline for delivery of this column on a specific date, and I'm a column. I know where I go in the overall structure. So these are my statuses. These are the statuses that change, that can be registered, that can be monitored. So, for instance, at some point, when the situation is, when it's about controlling, and you will see that the manufacturing is lagging behind, the column will not be produced by that time, by that deadline. We see a delay at once, and this is something we can address before we face it. And this kind of interaction, this kind of monitoring, this kind of supervision is very important. When 4D, when I'm being shown some 4D pictures or imagery, I'm asking, what's that? Is it already for sale? If I'm supposed to visualize status, something that you're going to see today, visualization of statuses in a presentation, you will see how it works. You will see how it comes together. What's important? This status management. This visualization of these layers, it makes no sense without management. And there is sequencing, there is sequential nature of things. They need to come together, they need to be sequenced. We show a video to those who fail to understand the set of drawings. There are sometimes visual aids or visual instructions that we have to give, and 4D models help us there. So planning and control of 4D and 5D. We know that there are file managers, we know that there are project managers, we know that there are resource planners, people who manage the workforce. These people know about various levels of planning. Only two of these levels are shown here. There is a level of very coarse or very rough planning, like this story will be completed by this time, that story by that time. So these are the flow line diagrams. I can show you around this methodology later on. It's on at the level of tasks, at the level of resources. The most important thing are tasks. It's about the foundation. For example, you need to build foundation and balance the resources. Each of these lines is a task. Who of you is working with Microsoft Project? 1, 2, 3. So some people have worked with Microsoft Project. So this is the way it is described in Microsoft Project. So the more inclined this, the more sloped this line is, the longer it takes to complete it. And the more upright this line on the chart is, the shorter time span it takes to complete it. And these other elements, these other fields, other pillars that you need to take care of, is about specifics. This task is split into specific elements, which need to be put together, which need to be monitored and supervised. And each day we make a report, what has been done, what has not been done, at which level, and then we receive this information, for example, to the central office. So think of it as a local picture, and the one that goes into the central office is on the right. So you will hear about this today. Task management, how it looks like. So some more words about this methodology. it's about the arrangement of workflows. There are several zones that you can see here. The building 1, building 2, first floor, second floor, first story, second story, and so on. So to avoid this overlapping, it's useful to visualize it like this. When we're talking about status control, it's for each element individually. I don't know whether element is the right word to use in Russian here, but anyway, the structural element, it's the right word, right? It's the column, it's okay to use this word. Okay, so if you remember, we talk about one thing, that model is integrated in this graph, and they are connected. So I, as a column, I know when I'm supposed to be manufactured. These are the deadlines right there. These attributes are right there. And at the construction phase, the construction site, when this column, or me, when I'm installed, I will change my status when my code has been scanned. So the column has already been put there, has already been installed. And this information, this small piece of data, this status update, will go further down to the system. And these points are the facts. The major dots, the major points, major dots, are something that's where we are going to be at a specific point in time. This is about resources. When some working team is working slowly, then we can respond to that. We can get them to work faster if we need them to. Okay, so beam in manufacturing, or beam in fabrication. It's not just about integration of machines into planning and manufacturing. When each column knows when it's supposed to be produced, I can use this XML, land XML format or another compatible format. I can take this to MIS systems. MIS stands for Manufacturing Information System. And these MIS systems understand models. I can, this metal factory that I gave it as an example, that factory knows models. They know every status in a model. And they know how to streamline their production accordingly. The barcodes are used in order to scan the parts or pieces that have arrived or they have left the manufacturing. So it's about continuous monitoring, it's about continuous feedback. It's not just plain geometry, it's much more than that. So how does this happen? For example, there is architectural model. People are sending it from AutoCAD, and they are communicating through IFC format between each other. And then at some point, we involve the manufacturer, and the manufacturer says, no, guys, it doesn't play like this here. It won't be the same as portrayed here. It will be somewhat different. Then this is the opportunity for us to adjust the picture, to arrange the picture, to agree on the common vision between us. And these pieces will be manufactured by that producer, by that fabricator, not by the drawings, but by the models, by the files. Reinforced concrete production systems, modern ones, look like this, and they can already do that if this technology is implemented. The principle is this. BIM is about the usage of data, it's about usage of this information. It's something that we try to communicate through drawings if we cannot use BIM. Sometimes the machine, the equipment cannot work with drawings. They need the models, and they need these files. And this is something that we can do now, these days, in Latvia. We're not that far advanced in Latvia. We are European Union, but not that far advanced. So in the Nordic countries, there are welding robots at work. We're not at that phase yet. So you can see this model of metal. You can see this design, this structure. We design reality, real life pictures. And this is what the machinery, or this BIM model, this is what the machinery visualizes. This is the image they get in their electronic mind when they get this file uploaded. So this is about putting these elements together. It's assembly line. Assembly line is the output. We'll talk about that later. Then we approach the construction site management level. Story by story, floor by floor. This is a living organism. So it matters a lot to properly manage it. This is the very same construction site. You see these blue stuff in the bottom of the right picture. These are construction materials. And in the middle, this is the same, this metallic scaffolding, or the metallic structures in this case. It's not temporary. So 1 week we plan that this corner of the construction sites will be occupied by building materials. The next day it will be used to store these structural elements, metal structures. So this is about managing the moving things that otherwise would have been mismanaged. We foresee the logistics. Otherwise would spend 30 times more time, 30% more time to move things around. And it's not necessary to move these things at all times. Okay, so for example, we put the construction materials in one corner and then we find out immediately that this corner is supposed to be used for something else. We can avoid that. This is about what coordination is about. So there are these booths or construction wagons, you know, these temporary structures. These are the smart boards that show the visual statuses, when everything should be done. The displays are used for various more complicated nodes. These 3D visualizations are used. So using 3D in manufacturing is already a big thing. It's already a big way to reduce miscommunication, or to avoid miscommunication. The simulation of 4D, meaning that the fourth dimension of time is taken into account. There is accountability for quantities, accountability for statuses, everything. To wrap up my presentation, I would like you to show this on-site control. So we send control points from our model to the construction site. How do you properly call it in Russian? This geodesic instrument. So these devices, this surveying equipment, helps us study the reality. We specify specific points that we need to check, whose status we need to check to see how we're doing well on time in the project. So for example, here we specify specific points and they are surveyed on site. As a result, we get some feedback from these surveying instruments, from these geodesic instruments, and we can upload it back to the model, and in the model we can see the deviations if there are any. It's a good thing that this is temporary construction. It's a good thing if it's false work, but what if it's not? We need to prevent any issues with quality. When we are at the stage of decking, when we're at the stage of doing this false work in concrete, this is about quality management and prevention of issues quality-wise. These are some of the companies that are using these things. These are the companies that apply the principles that I've mentioned. There are some names here on the board. Most of them are quite well-known companies in the world. Many of you should know them. General contractors, major contractors. This is the way they work. What's the situation in Lithuania and Latvia? It's closer to our area, right? So in Latvia, we use the BIM is used by PST, one of the major construction companies. Nobody was forcing them to move into BIM. They have done it for themselves, and they adjust, or they orient all the constructors, all the contractors to work with this BIM environment. They are already doing 4D with their contractors. YIT is a company famous in the Nordic countries. Consoles, you may have heard about this. It's assembled reinforced concrete console. Marcucci, they will represent their working methodologies. They are the strongest. We have two major companies that I can point out. It's Marcucci and B Group, or Group B. These are not the designers. These are fabricators and constructors. So of course, some of them have their own designers. Some of them work or cooperate with designing companies. The Lithuanian practice, I can show you the website for the contest for best open BIM models. This year we have had the contest for the best integrated models. There were 14 projects for the first phase of that contest. One of our guests, Mr. Galap, was part of the jury. They were evaluating these projects. I won't waste too much time. Who of you does not have internet access at all? Everybody has internet access, right? So thank God we're there. So just log into this website. BIMforum.lt means Lithuanian. BIMforum.lv means you go to the Latvian guys. So BIMforum.by, you go to this conference without video recording, without videos uploaded. But in some weeks we will upload the video. At each conference we are doing videos. Those who have been absent from the conference will be putting the video out. So you can check out this Open BIM Awards. You will not understand the Lithuanian because the website is in Lithuanian, but you will understand the videos. And the videos show the models, and the models are pretty self-explanatory regardless of the language. All these models will be sent to you electronically if you want. It's better to look at the PDF than a picture and photograph. What will be the conclusion? Well, in principle, we need to work with customized solutions, with professional solutions. The most important thing is that we have an option, that we have options to choose in the designing sphere. Various solutions, various technologies, but these technologies can work together, no problem. The same goes for Revit. Revit is a very popular AutoCAD product in Lithuania. Over 50% in Lithuania. 30% in Lithuania work with AutoCAD. There is EliteCAD, some other technologies which are not that widespread. But what the structural engineers are supposed to do? They are supposed to work with many projects, with many products. For example, some foreign company can come around with can come by with a very good architectural project in a different format. So what do? Well, they have to adapt, right? So we have a lot of materials, we have plenty of videos, plenty of materials on our website. They even show the examples of the projects, how it happens, using BIM. So, we are talking about the technologies that are encompassing the entire cycle. It's not, we're not talking about that too much right now. But there are some clients that are using these technologies. That's systems for building maintenance and supervision. These systems around BIM, again, they're centered around BIM. This is not space technology, this is not rocket science, it's already operational. So, this is it.